classroom, but also in the real world. So let's define slope real quick. Slope can be defined as the ratio. Remember, ratio is just a fancy word for fraction. Write ratio, don't write fraction. Trust the process. The ratio between, now I'm going to warn you right now, this definition is not going to make sense until we look at it. So we'll just get it written down and then we'll talk. Slope can be defined as the ratio between the change in y value and the change in x value from one point to another on a line. Now that's our confusing math definition. Let's write it in simpler terms. It's the measure of how steep a line is. Anyone in here ever been hiking before? A couple people. A little bit more accessible than snowboarding, especially here in Sacramento. So if you were hiking up a steep hill, what type of hill would that be?
A slope hill.
A slope hill? Good, I like that. If it's really steep, right, would it be easy to walk up or difficult to walk up?
Difficult.
Difficult. Why is that?
Because it's uphill.
Because it's uphill, exactly. So if you have a steep slope, you're walking uphill, right? So slope is the measure of steepness. If you're going downhill, right, that would be, well, we'll get to it, but that would be like a negative slope. That'll be tomorrow. So for our lesson from yesterday, right, the constant of proportionality is very, very similar to this idea of slope. In fact, they're the same, but slightly different. So we used K for constant of proportionality. What letter do you think we're going to use for slope? X. That's a good guess.
Z.
Z. S. S is a great guess. We're going to use M.
Y.
I do not know. That's a great question as to why. I assume it has something to do with the either Greek or Latin spelling of slope. It probably starts with an M in Greek or Latin. Pretty much all the math that we use and know today comes from the ancient Greeks and the ancient Greeks, Pythagoras and all those people. Angel, go ahead. Yes. I'll put you on the list. So M is going to represent our slope, and M is equal to, we're going to have another ratio, so a long fraction here. The change in y over the change in x. Now change in y, we're going to represent that with this weird little symbol. It's a triangle y. And the change in x is going to be a triangle x. And that triangle in math is called delta, which does come from the Greek alphabet. If you're reading something that was written in Greek, any letter D that you see is going to look like a little triangle. Delta is the Greek version of our English letter D, and it represents a change. So the change in y over the change in x. Just to make it a little bit simpler, a little easier for us to remember, we can call this rise over run. Does that sound familiar to anyone? Rise over run? No? Good. And it's new for all of us. We're all going to learn together. Think about our coordinate plane. Is the y-axis up and down or left and right? Y-axis. Up and down, right? So if you're rising, right, if something is rising, like bread in an oven is rising, then it's going up. So the change in y is rise. Yes, and they even rhyme. That long I sound. Y and rise. Is our x-axis up and down or left and right? Left and right, right? So it's horizontal. If you were running, you're running along a horizontal or flat surface. Yes? So the change in x we call run. Slope is just the ratio or fraction of your rise over your run. I know that doesn't make sense yet, but it will once we take a look. Let's also go ahead and define a slope triangle. And we're going to draw one of those here in just a few minutes. So a slope triangle is something we're going to draw on our graph from one point to the next. And it's a visual representation of the change in y, or rise, and the change in x, or run. Everyone's going to get a little graph square as you're catching up with your writing here. We're going to glue this little graph right in here. Fellas okay up there?
Yeah.
Good. What's up? What was the spirit today? Oh yeah, we're black.
Why would you
Thank you,
have a
Michael.
conflict meeting? It wasn't there. Why would you have a conflict?
You're welcome.
It's like if you had like PE, right? You just kept dropping shit on. I got tired of it, so I pushed him and we got a 5. But
Make sure everyone in your group has a little graph square to glue in.
no, so all I did was push right, and they took it so seriously that I get into the office from second period all the way to 6th. Thought you didn't see me at lunch. Thought you didn't see me at lunch.
Yes. Perfect. I'll grab it. Thank you.
Hey, one of these, I got. Adrian's gonna double team. Three people on. What? I get raped. There's no need for people taking it. I just understand this guy was just
Let's go ahead and get it started. Or is everyone still gluing? I see glue sticks out, so we'll wait a few minutes. soon as you're ready to go, you can put your glue sticks back in the supply box so I know you're good. Make sure you have a ruler on hand ready to go from your supply box and as well. Just grab one of the, or yeah, if you'll have a ruler. All right, we're going to plot 2 points here. The first point's going to be at 4, 3. 4, 3. Second point's going to be at 8, 6. 8, 6. You're going to take your ruler. You're going to connect these 2 points together, making sure that you go through your origin as well. Just like that. Write in the coordinates, but please make sure you write your coordinates underneath your line. It's going to be extremely important once we draw our slope triangle. Yeah, there's tissue over here if you need it. We'll all go ahead. So we're going to follow a couple steps here. The first step is we're going to start at your leftmost point. Everybody knows they're right and they're left, yes? Hopefully. What's that? Start at your leftmost point. So if we're looking at this graph, would my leftmost point be 4, 3 or 8, 6? 8, 6. 4, 3. If you ever forget your left and your right, just hold out your hands like this. The hand that makes an L, that's to the left. So that'll be 4, 3 right there on the left. No notebook today, Ranveer?
Huh?
No notebook today? So we're going to start at our leftmost point. We're going to count the rise which is our change in Y. Marvin, thank you. Because we're rising, that's our change in Y. We're either going to go up or down. Until you're in line with your second point. I'm going to zoom in so you can see a little better. So let's go ahead and do that second step. Step 1, we're going to start at our leftmost point right here, 4, 3. That's on the left. Yes.
Oh, I was making shit out of my life.
Oh, yes. Okay, good. Left. And we're going to count up until we're in line with this second point. So I'm going to use a ruler to show that there's the line I'm trying to get up to. All right, there's my second point. Block it off after that. And we're going to count how many spaces we're going to rise. Are we going to rise up or rise down?
Rise up.
We're going to rise up. 1, 2, 3 spaces. We hit that line. We're in line with our second point. Our rise is going to be 3. From there, we're going to do step 3. We're going to count the run, or our change in x,
Wait, I don't-
left or right, until you land on your second point. So we're basically mapping out how to get from our left point to our right point. But we can only go up or down and left or right. The diagonal between those 2 points is the line itself. Hopefully you see what I'm talking about. I'll give you a second to copy that down and we'll do the run together. So we went 3 spaces up, that's our rise. From this point, we're now going to go a certain amount of spaces over. Now, if we want to land on this second point, do we have to go left or right?
right?
We have to go to the right. 1, 2, 3, 4 spaces. And that's going to be our run. Last step, step 4. We're going to place your rise and your run in a fraction and simplify if you can. Not always going to be able to simplify, but if you can, we will. So the formula to find slope is almost identical to the formula to find k, except instead of just taking a y coordinate and putting it over its x coordinate, we're finding the change from one x coordinate to the next and the change from one y coordinate to the next. That's why we call it rise over run instead of just y over x. So from our graph, what was the rise that we found again in orange? 3. What was the run that we found in green? 4. Can we simplify 3 over 4 at all? No, we cannot. Our slope of this line is 3 over 4. So let's write in the slope of this line is 3/4. No, because we're not going to get through this whole lesson. You're not understanding? Which part is getting you all tripped up?
Actually, I think I can.
That's okay. Yeah, talk me through.
So once we find out these, once we find out the points,
Yes.
we have to.
So the drawing the line part will be done for you. You'll see 2 points. You start from the left, you count up, you count over, you put the up over the over. That's simple.
When do we ever go right?
Great question. We're going to take a look at this second graph. Don't glue this second graph in just yet. I'm going to show you where I want it. Everyone get a second piece of graph. I'm going to have to flip mine over, but if you have room for this second graph, by all means, keep it on that side.
That guy arrested like 20 more. Yeah, Sean Watson You must know what that is. Do you not? I feel like you would know what that is. Oh,
Everybody doing all right?
Yeah.
Perfect. Here's the second line that you are graphing. 5, 8 is your first point. 8, 2 is your second point. Get that glued in. Get that line graphed. Sean, everything okay? Okay, let's take a deep breath and finish our notes, please. What's the first thing you notice about this line that's a little bit different than what we've been seeing?
It's right.
It doesn't start at 0. That's right. What do you need? Someone's in.
Both sides, that's one to the
We
right.
have time for that.
Because it's easy.
Yep.
It's just because the paper's
Okay.
red.
Why are you talking?
26. We have
Yeah.
15.
Focus on your work.
Good, that's easy.
1226. So, we got this point here. We notice that it is not going through the origin. Is it a straight line though?
Yes.
Yes. So is this proportional or non-proportional? Non-proportional. Good. So, we're going to draw our slope triangle. Which of these points are we going to start at? 5, 8 or 8, 2? We're going to start at 5, 8 because it's on the left-hand side of our graph.
But they're both on the left.
So,
I'm not understanding.
no, okay, I got what you mean. So, if we're just looking at these 2 points, right? This point is on the left, this point is on the right. Yes, they're both on the right side of our graph if we were looking at a full graph, but we're talking about in relation to each other.
Right.
You see what I mean?
Yes, I'm
Good. So we're going to start at 5, 8, and we're going to rise. But what direction are we rising if we want to be in line with 8, 2? Up or down?
down.
If we're starting here and we want to line up with this point, are we going up or down?
Down.
We're going down. Let's count it out. 1, 2, 3, 4, 5, 6. We went 6 units down. From there, are we going to go right or left?
Right.
We're going to go to the right. We're trying to land on this point. So we're going to go to the right. 1, 2, 3. What we just drew here, if you can see it, is the slope triangle. That's that second definition that we wrote. A slope triangle is a visual representation of how to get from one point to the next. It's kind of like directions. If you're driving somewhere, or biking somewhere, or scootering somewhere, however you get around, walking. You can't just cut across. You got to go down this street and then turn and go over on this street. Same kind of thing. So this is where we have to be careful, and this is why we're doing a second example. M is equal to our rise over run. How many units was our rise again? 6. Now, because we had to rise down, our numerator is not just going to be 6. Anyone want to take a guess at what it's going to? -6. When we go down, when we rise downward, our rise is negative. Well, let's write that in. When we rise down, our change in y is negative. This is why we always start with the leftmost point. So we can tell right away whether we have a positive slope or a negative slope. How many units was our run?
3.
3. Can we simplify -6 divided by 3? Yes. What do we get?
-2.
-2. Therefore, m is equal to -2. The slope of this line is -2. Does that negative slope make a little sense?
Yeah.
So we're not going to have to write this down just yet. I think we'll add it in tomorrow. But I want to show you an easy way to remember or to tell whether we have a positive slope or a negative slope. So we've got a coordinate plane here with a line like this. We've got, no, you don't have to write this down. We're going to add this in tomorrow. So this green graph represents a positive slope. Stay with me, please, guys. And this red graph represents a negative slope. You have a question again? Okay. So if it's hard for you to remember that when we rise down it's negative, here's what you can do. On the left side of your line, you're going to draw a little stick figure. You don't need to write this down. I said it 3 times.
Oh, I'm understanding.
Just visualizing it. So on the left side of your line, you're going to draw a little stick figure. Notice how they're in different positions. That's going to tell us right away. So if you told your little stick figure guy or lady to walk this line, let's take a look at the green graph first. Would this stick figure guy or girl have to walk uphill or downhill?
Uphill.
Uphill. If you're walking uphill, the slope is positive. What about this little stick figure guy or gal over here on this red line? Would they walk uphill or downhill? Downhill. So when you're walking downhill, that is a negative slope. Give me a thumbs up if you visually see what I'm talking about. Beautiful. And for the 8, 9, 10 of you that don't have your thumb up, I hope you eventually do understand. We'll get to it more tomorrow.